Okay, picture this. A top mathematician, someone who spent years, maybe their whole career, wrestling with these incredibly tough problems.
Right.
They're staring at this one problem. It's called a stubborn combinatorial conjecture that stumped researchers for ages. You know the type. Beautiful, elegant, but just impossible to crack.
Completely stuck.
So they decide, maybe half skeptically, to feed it into this new AI tool, Gemini 2.5 Deep Think. And what happens next just...
Well, it blew them away.
Yeah, spectacular was the word they used. The AI solved it. Just like that,
Yeah.
instantly.
Instantly.
Pretty much. But here's the really mind-bending part. The solution, the proof Gemini found, it wasn't anything like the human approach. Not even close.
So not just faster, but different.
Totally different. It apparently explored, hundreds of potential paths simultaneously before locking onto something completely novel. The mathematician described it as feeling, and I quote, frankly alien. It wasn't just calculation. It was this really expansive, almost creative reasoning. Wow, okay, that's a big claim. So we're not talking about incremental improvement here. This sounds like a whole new way for AI to think, this parallel multi-agent thinking. What exactly is that? How does it work?
That's the key question, isn't it? It represents a fundamental shift.
Right. So today, on this deep dive, we're digging into exactly that. Gemini 2.5 DeepThink's breakthrough math skills, what these Gemini math benchmarks are telling us about AI's future, human-machine teamwork, and crucially, what it all means for you.
Exactly. And it's fascinating because these benchmarks, they're really rewriting the rules. We're moving past just number crunching into something that looks a lot like genuine creative mathematical reasoning.
Let's talk about one of those benchmarks then. The International Mathematical Olympiad, the IMO. That's like the Olympics for math whizzes, right? The absolute peak.
It really is. We're talking 6 incredibly difficult problems, 4.5 hours to solve them. No calculators allowed, just pure brain power. Getting any medal is a huge achievement. Gold, that's legendary status.
So for an AI to not just compete, but actually excel there, what does that tell us? How significant is that?
Oh, it's hugely significant. Back in July 2025, there was this advanced internal research version of Gemini 2.5 Deep Think. They gave it the official IMO problem set.
The real deal.
The real deal. And it scored 35 out of 42 points. That's slap bang in the middle of gold medal territory.
Wow.
And importantly, this wasn't some AI grading another AI. The scoring was done by the exact same human coordinators who grade the papers from the human contestants.
Okay, so proper validation.
Absolutely. Professor Gregor Dolinar, who's the IMO president, even confirmed it. He said the AI solutions were, and I quote, clear, precise, and straightforward to follow.
Clear and precise. That's amazing. So it wasn't just getting the right answer, it was explaining its reasoning in a human understandable way.
Exactly. Now, to be clear, Google hasn't released that specific gold medal version to the public.
Okay.
What they did release to Google AI Ultra subscribers was a slightly, let's call it a pared back version. But even that version scored 60.7%. That's still a certified bronze medal grade.
So even the public version is superhuman at this. Bronze medal is still incredibly impressive.
Definitely. Both versions are way beyond previous capabilities. And this is where the Gemini math benchmarks really paint a picture. If you look at the scoreboard comparing DeepThink to others like Gemini 2.5 Pro, OpenAI's O3, Grok 4,
Competitors.
across different tests, the IMO 2025, another tough one called AIN 2025, even general reasoning tests like Humanities Last Exam Without Tools, and code generation. DeepThink is just way out ahead.
Like how far ahead?
Well, on AMA 2025, DeepThink hit 99.2%. That's near perfect and significantly higher than the rest. On the IMO, the public bronze version already substantially beats the others. It's not just a step up, it's a leap.
That scoreboard does make it pretty clear. But you said earlier the how is just as important as the swarm thing. How does that actually work under the hood? It's not the old single-track approach.
No, not at all. That's the paradigm shift. Instead of one line of reasoning, Gemini 2.5 Deep Think, basically, well, it unleashes a whole swarm of thinkers.
A swarm? Like bees?
Kinda, yeah. Imagine a big conference room, but it's packed with these miniature AI analysts. Each one starts drafting a possible solution, like a rough outline of a proof.
Right.
Then there's another group, a critic panel. Their job is to attack every single line of reasoning proposed by the first group. They try to find flaws, shoot holes in the arguments.
Ah, sounds like academia.
Doesn't it?
Yeah.
So only the strongest arguments survive this critique. The successful ideas get merged, the weaker ones just fade out. And what comes out at the end is this polished, combined result, this consensus proof, written in plain English.
So it's like internal peer review on hyperdrive.
Exactly. One analyst described it perfectly. Think of engineering a team of argumentative interns in silicon. They fight over lemmas until consensus emerges.
Argumentative interns in silicon. I love that. And this is a big jump from older systems like AlphaGeometry, right?
What is that?
The key differences.
Two massive leaps. First, input. AlphaGeometry needed problems translated into a formal computer language. DeepThink understands natural language. You can just type the problem in or describe it.
Much easier.
Way easier. Second, speed. AlphaGeometry took like 2 or 3 days to solve complex geometry problems.
Gemini Deep Think did the IMO problems under the official 4.5-hour time limit.
Inside the competition window.
Precisely. And it hit that gold medal score where previous systems were more at the silver level. It really crossed a significant human benchmark.
Okay, so it's clever, it's fast, it understands us. But how does this translate from, winning math competitions to actual real-world use? Are people using this now?
They are. Developers are already taking these capabilities and integrating them.
Like that example you mentioned earlier with the restaurant software.
Yeah, Kareem Channing, the tech entrepreneur, he basically said they used Gemini Deep Think plus iterative prompting, so back and forth conversation, to build their optimization algorithms. Each cycle, the AI helped them refine it, shrink the error margins. It's becoming a tool. That's practical. Can you give us another example, maybe something that really shows off that alien reasoning you mentioned, something that stumped humans?
Definitely. The partition identity conjecture is a fantastic example. It gets cited a lot. It's this really elegant problem connecting integer partitions, ways of summing numbers to binomial coefficients.
Okay, sounds mathy.
It is. Humans knew it was true for small examples they could check it. But finding a general proof that worked for all numbers, that was incredibly hard. People kept getting bogged down in really messy, complicated case-by-case arguments. Just stuck.
Right, a classic case of knowing what but not why, universally. So what did DeepThink do?
It didn't even try the messy combinatorial path that humans were stuck on.
Oh!
It did something completely different. It reframed the entire problem using something called hypergeometric transformations. That's a pretty advanced technique from a whole other area of math.
So it brought in tools from a different field.
Exactly. By essentially changing the language of the problem, it found this hidden structure. And suddenly, this complex, sprawling mess condensed down into a beautiful, clean, one-page proof, all written in natural language.
And that's where that quote comes from, the mathematician feeling awe and jealousy.
That's the one. It proved it right away, and the proof wasn't even in the ballpark of my approach. It wasn't just problem-solving. It showed genuine insight, finding a more elegant, creative path than the human experts had conceived.
That really underscores the difference. Okay, so we're seeing these benchmarks, IMO, AIM, this conjecture. Why are these benchmarks making such waves? There are tons of AI benchmarks out there. What makes the Gemini Math ones special?
Good question. I think it's two main things. First, the tasks themselves are incredibly rigorous. Olympiad problems, especially, are designed to kill partial solutions or clever tricks that don't fully work. You need the whole logical chain, start to finish, or you get nothing. No points for trying.
Unforgiving.
Totally. Second, the evaluation is transparent and human verified. It's not just a score spit out by a machine. Real human experts, the IMO graders, check the proofs line by line. That builds trust.
And you mentioned people are saying the proofs are actually clean, like well-written.
Yeah, that's a common comment. Reviewers are saying they're often clearer than, say, typical undergraduate homework submissions. You can actually download them, follow the logic step by step. It's very accessible.
That transparency must be driving interest.
It seems so. Google Trends saw a big spike, like a 3-fold jump, in searches for Gemini IMO benchmark and can AI solve unsolved math problems, right after the news broke in July. And educators are noticing too. People are already designing courses that use AI walkthroughs alongside traditional texts.
Which leads nicely into this idea of the human-machine loop. How does that actually work in practice for mathematicians?
Well, it mirrors what we see in other complex fields, like engineering. The most effective approach seems to be humans provide the direction, the intuition, the goal. The machine generates lots of possibilities, explores avenues very quickly. Then the human comes back in to curate, to prune, to guide the process based on the results.
So steer, generate, prune.
Exactly. A researcher might have a hunch, they feed it to Gemini. Gemini explores way more paths than a human ever could. And then the researcher looks at the outputs, picks the promising threads, and guides the next step. It's a partnership.
It really does sound like a partnership. And this is becoming a real field now. AI for mathematicians.
Oh, absolutely. It's moving past being just a novelty. You're seeing conferences actually dedicate sessions to this large model problem sessions,
Yeah.
where mathematicians actively use these tools to tackle open problems together.
That's fascinating. And the potential impact goes way beyond pure math, right?
For sure. Any industry that depends heavily on symbolic reasoning, on logical proof, think cryptography, making sure encryption is secure, formal verification, proving software is bug-free, even finance, like high-frequency trading algorithms. A tool that can find creative logical paths or spot hidden flaws is potentially revolutionary. DeepMind's math research isn't just academic anymore, it's feeding into their product plans.
Okay, this sounds incredibly powerful. But there's always a but, isn't there? You mentioned a limit for public users.
Ah, yes. The slightly less glamorous reality. For public users accessing DeepThink, at least currently, there's a limit. Just 5 messages per day.
5, that's it. That seems really low for deep mathematical exploration.
It does feel restrictive, yeah.
Yeah,
Is it a
sure.
technical bottleneck? Is it cost? Google says it's mainly for cost control and safety while they scale things up.
I can imagine the frustration, though.
Definitely. There was a PhD student from ETH Zurich talking about this. They said something like, I'm trying to work through a proof by induction. 5 turns disappear before I even properly establish the base case. The model's amazing, but the limit breaks the workflow.
Yeah, that sounds painful. So what are people doing? Any workarounds?
The common strategy seems to be a hybrid workflow. People use the standard Gemini 2.5 Pro, which has higher limits, for the initial brainstorming and exploration. Then, when they've narrowed things down to a really tricky step, then they burn one of their precious 5 Deep Think credits for the heavy lifting.
Smart, but not ideal.
Not ideal, no. Google engineers keep saying higher quotas are coming. But it does highlight a crucial point. The best model in the world doesn't help much if access is too constrained.
Right. And this power also brings up some tricky ethical questions, doesn't it? Especially for mathematics, which relies so much on openness and peer review.
It really does. The whole social contract of math is built on transparency, on being able to check someone's work. If an AI can generate proofs faster than journals can even review them, who gets credit? Who has priority?
And what about authorship? If it's this swarm of critic agents debating internally who actually authored the proof, the human who prompted it, the AI, Google.
These are the big questions everyone's grappling with. Demis Hassabis from Google DeepMind talked about this. He suggested we're moving towards models of shared authorship, or needing explicit acknowledgement of the AI's role as standard practice.
Like citing software today, but more integral.
Kind of, yeah. Maybe something like we see in big physics experiments like at CERN, where papers have thousands of authors listing everyone involved. Or maybe a human steward model emerges. The human who asks the key question or framed the problem gets lead authorship, and the AI gets a specific kind of citation, maybe in a footnote. Journals are already scrambling to create guidelines for this.
It's a whole new landscape for academic credit. Okay, so the public has the bronze version now. What's next? Does it get better?
Based on Google's track record, almost certainly. They typically have these more advanced internal versions, the gold-level research tier we talked about. Then they release a strong but maybe slightly dialed-back version publicly, the bronze. Over the next, say, 6 to 12 months, they usually close that gap.
So we can expect the public version to climb from that 60.7% towards silver and eventually gold levels.
That's the pattern, yeah. They do it through more training, feeding the AI massive amounts of generated proofs, what they call synthetic proof corpora, basically, giving it more practice problems, and also by making the internal swarm more efficient, improving how those agents debate and reach consensus without using excessive computation. The swarm scheduler gets smarter.
Better study guides and better teamwork for the AI interns.
Pretty much. And having these clear, objective Gemini math benchmarks puts pressure on them to keep improving. Everyone's watching that score tick upwards.
And it's not just Google watching. You mentioned startups are already jumping on this.
Immediately. The moment the public version became available, even with the limits, companies started integrating it.
Can you give some examples?
Sure. There's a company called Lambda Factor. They work in formal software verification, proving code is correct. They're using DeepThink to automatically generate things called candidate loop invariants, which are crucial for these proofs. They claim it's cut the manual proof effort by something like 60%.
Wow, 60%. That's huge.
It is. Another one, Cryptoptic, works in cryptography. They feed security proofs for things like elliptic curves, the math behind a lot of encryption, into the model. DeepThink hunts for subtle weaknesses or patterns that humans might miss, and apparently spits out potential attack vectors.
So it's acting like a security auditor.
A very creative, very tireless one. The key for both these companies is that they need an engine that doesn't just find an answer, but finds creative routes, explores possibilities under tight constraints. That's DeepThink's sweet spot.
This must be changing education, too. How do you teach math when students have access to a tool this powerful? Is it cheating? Or is it a new way to learn?
That's the debate. But coaches, especially for things like the Math Olympiad, are already integrated the bronze version into training. Not as a way to just get answers, though.
How are they using it then?
The approach seems to be, first, the student tries the problem completely on their own, really struggles with it. Then, after they've hit a wall, they use DeepThink, but maybe just to ask for a strategic outline or a hint, not the full solution.
Ah, okay, like a nudge.
Exactly. Then the student has to take that outline, that sketch, and rewrite the full proof in their own words. The idea is it helps them understand the structure, the key idea, without just copying. It reinforces learning.
That sounds a lot like how chess players use chess engines.
It's a perfect analogy. Chess players didn't get replaced by engines. They used them to analyze their games, see lines they missed, understand deeper patterns, and ultimately become much stronger players.
So fear turns into partnership, which turns into an essential tool.
That seems to be the trajectory. AI for mathematicians likely follows that same path.
Okay, but it can't be perfect yet. What are the big open questions? What keeps the researchers up at night about this technology?
There are definitely still some major research challenges. One is robustness. Can you trick the swarm? Can carefully crafted adversarial prompts make it accept a false statement, a fake lemma, deep inside a complex proof? Single mistakes are rare now, but maybe complex deception could work.
Security for proofs.
Kinda, yeah. Another is explainability. We get the final proof, and it's readable. But that whole internal debate, the back and forth between the critic agents, that's still a black box. Understanding how it argues internally could unlock even better reasoning.
Seeing the rough work, not just the final essay.
Exactly. Then there's generalization. It's great at Olympiad-style problems, but can it handle the breadth of higher mathematics? Things like algebraic geometry, category theory, analytic number theory. These fields have different styles of reasoning.
Pushing it beyond its current comfort zone.
Right. And finally, scaling. If you make the swarm 10 times bigger, give it 10 times the computing power, do you get 10 times the performance? Or do the returns diminish? Early signs suggest it's not linear. There are diminishing returns. But clever software design keeps pushing that boundary.
Lots to figure out still. And presumably, the answers feed back into improving the model and updating those benchmarks.
It's a continuous cycle. Discover limitations, research solutions, improve the model, test against new benchmarks.
Now, inevitably, when something like this happens, AI gets an IMO gold medal. The headlines scream, AGI is here, Skynet is coming. What did the actual researchers say about the timeline to artificial general intelligence?
Yeah, the hype is real. But the researchers themselves tend to counsel patience. AGI means flexible, human-like understanding across all domains, not just math. Math is super important, a key indicator of reasoning, but it's still just one slice of the intelligence pie.
So impressive, but not the whole game yet.
Not yet. But the rate of progress shown by these Gemini math benchmarks, it's making even normally conservative scientists maybe shorten their private timelines a bit. It's moving fast.
What's the feeling among mathematicians themselves? Are they worried about being replaced?
Some initial anxiety, maybe? But the dominant feeling seems to be excitement. Fields medalist June Smore had a great quote about this. I'm not worried about my job, but I'm excited. If AI can clear away tedious proof searches, we can chase deeper ideas.
That's the amplification idea again, not replacement.
Exactly. The narrative is shifting. It's about human intuition guiding the AI's powerful search and parallel creativity. It's about forging discoveries together that neither could manage alone.
So looking ahead after tackling the IMO, what are the next big mountains for AI math to climb? What should we be watching for?
The community often talks about two major targets now. First is the Putnam competition. That's the big undergraduate math contest in North America. It's notoriously difficult, full of clever problems and analysis, algebra, number theory. Success there would show real maturity beyond Olympiad-style problems.
Okay, the Putnam. What's the second one?
The second is, well, it's more ambitious. Parts of the Langlands program.
Whoa, Langlands is deep. That's connecting whole fields of modern math, right?
Exactly. It's incredibly abstract, deals with deep unifying theories. Even making limited, verifiable progress on conjectures within the Langlands program would be a massive test of the AI's ability to handle abstraction and reason across different mathematical structures. That would be a very serious benchmark, maybe even hinting at AGI-level reasoning.
So Putnam for breadth in undergraduate math, Langlands for depth in modern research math.
That's a good way to put it. And you can bet that progress, or lack thereof, on those fronts will become part of the ongoing Gemini math benchmark story.
What a fascinating journey we've covered. Gemini 2.5 Deep Think really does feel like something new, not just bigger models, but this coordinated chorus of agents. Structure matters as much as scale.
hmm And these benchmarks, the IMO score, the A score, solving that conjecture, they're not just numbers on a chart. They feel like concrete steps, steps toward a future where human insight and this new kind of machine creativity genuinely work together.
It makes you wonder, doesn't it? What's the next big leap? Will it be even bigger swarms? Or will it be some breakthrough in efficiency, getting this gold-level reasoning onto, say, a laptop?
Either way, the loop between human curiosity and machine-assisted proof gets tighter. The old image, the lone mathematician scribbling in a notebook, that image doesn't disappear.
It just gets a collaborator.
Right, a digital companion that can explore wild ideas, test crazy hunches in minutes instead of months.
And the implications spread far beyond math. Imagine chemists designing molecules, economists modeling markets, maybe even judges analyzing legal precedents, all working with AI partners that are fluent in complex arguments.
That collaborative future seems increasingly plausible.
It really does. It started with one stunning proof, but the road ahead looks even more exciting. Definitely need to keep an eye on that scoreboard. More Gemini math benchmarks are surely coming, and every update seems to tighten that weave between silicon thought and human ambition.